So in this video, we're going to do a few practice problems from your textbook. This would be in section 4.2 for the videos that I made that go over these concepts here. I believe they're in section 4.3b, solving variables when you have fractions. So make sure you watch those videos if you have any issues with that, and also watch this video here. If you do have questions, you can send them to my email, but what I recommend is that you also send me your work as a picture so I can see what you attempted and then give you some feedback there because maybe you were on the right track and you just didn't know. But these are good questions that I do want to show you how to do because you do need to become comfortable with these fractions. They won't disappear. You're going to need them. You're going to need to become comfortable and learn how to work with them when you see them, from grade 9 math to grade 10 math and onwards if you continue in that as well. So it's just a matter of comfort. Once you get it, you'll get it and things will make more sense. You'll struggle at first, but you'll get the idea later. I'll do question C first, then I'll recommend that you pause the video and then try the other questions after to see if you're on the right track. Then you can unpause and verify to see that you did everything correctly. So for question C, you'll notice that we have a fraction. Our denominator is 4. And when we have fractions, we want to get rid of the fractions from all the terms. And to do that, you multiply by the lowest common denominator. In this case, there's only one denominator. So we're going to multiply everything by 4, all the numerators by 4, and that'll allow us to get rid of that 4 at the bottom there in the denominator. When we do that, then it's much easier to solve for our variable, our w over here. So what this means when you look at this is that the w plus 3, they're all over 4. Another way to write this, and I'm just going to rewrite this to show you what it can also be rewritten as. This can be rewritten as w over 4 plus 3 over 4 is equal to 2. When two terms are added together or even subtracted and they're over the same denominator, you can actually just make one big line and put that denominator there once. So you don't have to rewrite it over again. But they have to be on the same denominator and they have to be added or subtracted to do that. So that's just another way of writing it, and you would approach the problem the same way if it was written this way instead, and that's how most of them are written in the video that I put up on YouTube previously. But I'm going to go and proceed with the problem written this way. So for question C, I'm going to multiply my numerators by 4. So you're going to do that to get rid of the denominator of 4. So you're going to have 4 times w plus 3 over 4 is equal to, now you need to multiply everything by 4. Because if you don't, then you're changing what the equation means. The equality doesn't apply anymore. So I even have to multiply my right side by 4 as well in the numerator area. So 4 times 2. And I know saying numerator sounds weird when it's not a fraction, but technically it is a fraction. We have 2 over 1. And that's why I said our lowest common denominator is 4 in this case. So what we're going to do is we're going to simplify this. So since I have 4 in the numerator and 4 in the denominator, I can cross that out, because 4 over 4 gives you 1. And so we're going to end up with w plus 3 is equal to 4 times 2, which is 8. And now you can solve this like you would solve any equation. Just isolate your variables. So w plus 3 minus 3 is equal to 8 minus 3. And then 3 minus 3 is 0, so we get w is equal to 5. And then you can go and you can verify your work by doing a left side, right side table. So the left side is w plus 3 over 4. And the right side is 2. And I want to verify that w is indeed equal to 5. So I'll go and place my 5 into my w here. So I get 5 plus 3 over 4 is equal to 2. And then I get 5 plus 3 is 8, so 8 over 4, 2. And 8 over 4 is equal to 2. So 2 is equal to 2. Because my left side is equal to my right side, what that means is that W is equal to 5 is a correct solution. And you would write that out as a sentence. If the fraction was written, if this question was written this way instead, you'd proceed the same way. It's just that instead you'd have to make sure you put your 4 multiplication here, here as well, and then here as well. And you would notice that the 4's would cancel out, like this, and you would still get your W plus 3 is equal to 8 in the end, and you would find your W is equal to 5. So same approach, just written a little bit differently. So at this point you saw how to do C. Now I'm going to carry through D, E, and F, but you should pause the video to try D, E, and F yourself, and then proceed to unpause the video to self-assess to see that you are on the right track. So I'm just going to erase the ink here so we can go and try examples D, E, and F. So for D, it's the same idea. We have y minus 5 over 3. And again, you could have written that as y over 3 minus 5 over 3 is equal to 6. We want to get rid of the denominator. So our denominator here is 3, so we're going to multiply everything by 3 here. So let's do times 3. Let's do times 3. 3 over 3, that cancels out. So now we get y minus 5 is equal to 6 times 3, which is 18. And then we get y minus 5 plus 5, to get rid of that 5 there, is equal to 18 plus 5. And then we get y, because minus 5 plus 5 is 0, is equal to 23. Then you can do a left side, right side table, or do a quick glance, just take a look. 23 minus 5 is 18, divided by 3, that's 6. So I know I did the right, I know I found the right solution. So that was for question D. Again, to verify, to show all your steps properly, as you would see in an assessment, I want you to do a left side, right side table. If I don't ask you to verify, just go do a quick little inspection, put that 23 in there in your head, minus 5, 18, divided by 3, 6, and you know you did the right job. So now we'll move on to E. So we have 2a plus 3 over 3 is equal to 5. And again, this could have been written in this fashion here, 2a over 3 plus 3 over 3 is equal to 5. But we're going to continue with the way it's written over here. So we have 2a plus 3 over 3, keep those brackets there, is equal to 5. And so we want to get rid of 3, so we're going to multiply everything by 3. Whatever you do on the left side, do on the right side as well, otherwise you're not really you're changing what the equation actually means. The 3 there and the 3 here cancel out because 3 divided by 3 is 1. And so we're going to have 2a plus 3 will be equal to 5 times 3, which is 15. And then we can go ahead and solve as you normally would. So 2a plus 3 minus 3 is equal to, do what you do on the left side, so 15 minus 3 on the right side as well. 3 minus 3 is 0, so we're going to have 2a is equal to 15 minus 3, which is 12. And then we're going to have to unmultiply. So the opposite of multiply is divide. So divide by 2 on this side, divide by 2 on this side. And that gives us 2 canceling out here. So that means that a is going to be equal to 6. 12 divided by 2 is 6. So you can do a left side, right side table to check your work, or you can just go and plug it in quickly by inspection if I didn't ask you to check your work. So 2 times 6 is 12, plus 3, that's 15. divided by 3, that's 5. That means A equals to 6 is the correct answer. So now we're going to go and try question F. So let's just erase the ink on the slide here first. Go back to our drawing. So F, same idea. We have to get rid of a fraction. So it looks here like we can get rid of this fraction by multiplying everything by 5. So we have, let me rewrite this here, minus 2 is equal to minus 2c over 5 plus 1. And we need to multiply every single term here by 5 because we're multiplying this by 5 here to get rid of the 5 at the bottom. Remember, when there's multiple denominators, you need to find the lowest common denominator and figure out what you're going to multiply every term by to get rid of it. Go take a look at that video on YouTube that I made previously on Google Classroom, and that will help you to solve when you have different denominators. So let's continue here. We're going to multiply everything by 5. So I'm just going to do that. Put brackets here. 5 times that, just so I don't get confused. If I didn't put brackets, it would look like I was doing 5 minus that. So it's 5 times negative 2. And then I'm going to put brackets here because I'm multiplying this by 5 as well. And then I'm going to put brackets here because I'm multiplying this by 5. Everything needs to be multiplied by 5. What you do on the right side has to happen on the left side as well, but what we're doing is we're getting rid of the denominators, so everything has to be multiplied by 5 here. So the 5 over 5 will cancel out. Great. And what that leaves us with is 5 times negative 2 is negative 10. That's going to be equal to negative 2c. 1 times 5 is 5 plus 5. And so now we're doing a simple multi-step solving situation here. So I want to get rid of the 5 on this side, so I do minus 2c plus 5 minus 5. And then I'm going to do minus 5 on this side as well, minus 10 minus 5, because whatever I did on the right side I have to do on the left side. And then I will get minus 2c plus 5 minus 5 is 0. Minus 10 minus 5 is minus 15. And then I'm going to divide by minus 2 on this side and by minus 2 on this side. And so the minus 2's cancel out, and I get c is equal to 15 over 2. And if I want to write that as a decimal form, and the reason this 15 over 2 is positive is because when you divide a negative by a negative, that becomes positive. If you want to write this as a decimal form, you would have c is equal to 7.5. That's a terminating decimal, so that's fine to write, meaning that you don't have other digits that follow, so I could put 7.5, or leave it as this improper fraction form, 15 over 2. And you can go and verify your work by seeing that the left side, right side actually work out to be the same thing. But if I do a quick glance, negative 2 times 7.5, so let me just do a quick glance check. You're going to do the left side, right side table. Negative 2 times 7.5 over 5 plus 1 is equal to, so negative 2 times 7.5 is negative 15 over 5 plus 1, and that's going to be equal to negative 3 plus 1, which is equal to negative 2. So notice I just did a quick glance what this would be equal to if I plugged in c is equal to 7.5, and it's actually equal to negative 2, so I did like a fast made left side, right side table, but you would have to follow the proper format, left side, right side, and plug it in and show that left side is equal to right side, therefore c is equal to 7.5 is a correct solution. So as you do more practice with fractions, you'll become more comfortable with them. It just takes practice. That's all it really is that's all it really takes to become good with these fractions. Practice, looking at your notes, watching YouTube videos, but actually doing it yourself is important.